A soccer ball is kicked horizontally off of a 12-meter high hill and lands a distance of 45 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. Now I've given you a different style of guess technique, but to be honest, I am going to draw a cartoon anyway. Of the situation. And so here is a student, and they have a soccer ball, and they kick it out down the hill. Let's see, and the soccer ball is kicked horizontally off of and we need to be careful about this, 12.0 meter high hill. Which axis is that? That is the x-axis. And so that is a distance, that's a y-axis. So that's a distance in the y is 12.0 meters. But do you know what direction the ball goes in? It goes this way. It goes down. So I'm going to apply a negative sign there. It also tells me that the ball travels a total of 45 meters, and that is the distance in the x. So I'm going to apply what I know in the y-axis. The distance is negative 12.0 meters. And I'm going to apply what I know in the x-axis is 45 meters. Okay, eventually I'm going to want to know what the initial horizontal velocity of the ball is. But I don't think that I have enough information. But I've given you information in the y. And now that you know information in the y, you know two things pretty much immediately. How fast, for a split second, does that ball move up or down as it is kicked? No, that means that I have 0 meters per second. And do I know how fast that ball accelerates in the y-axis? I certainly do. It's negative 9.8 meters per second squared. Once I have these three things, I can kind of ignore velocity final because this right here is my target. I want to figure out time. Because once I have time, then I can move from the y-axis into the x-axis. So I need to figure out a phenom that deals with distances, velocity initials, accelerations, and time. My handy-dandy phenom that goes distance equals velocity initial times time plus 1/2 acceleration times time squared. Let's replace numbers for letters. That's negative 12.0 equals velocity initial is 0 times time plus the quantity negative 9.8 times t squared over 2. This blows up because I'm multiplying by 0. I'm going to simplify. Negative 12.0 equals negative 9.8 times t squared over 2. In order to simplify the right side, I'll multiply by 2 because that's where my unknown is. Negative 24.0 equals negative 9.8 times t squared. In order to get t squared all by itself, I'll divide by negative 9.8. Cancel, cancel. Whatever I do to the right, I'm going to do to the left. Giving me a result of t squared equals 2.448979. Take the square root, t equals this number 1.564921 seconds. Now, if I make it pretty I have three significant figures here, and so it would be 1.656 seconds. Now, I can put 1.56 seconds here, or I can put a more accurate number so that the second set of calculations that I make are going to be even more accurate. Now, I know a distance, I don't know a velocity initial, and really I don't know a velocity final, but do I know that these two numbers are going to be the same? Does the ball in the x-axis have a constant velocity? Is it speeding up? Is it slowing down? Is it accelerating? Is it decelerating? If the answer no in all of those questions, this is 0 meters per second squared. The equation that I'm going to use that deals with distance, velocity initials, accelerations, and time, it looks very familiar. I'm going to replace distance with 45. I'm going to replace velocity initial. I don't know what it is, but my time is 1.56491 plus the quantity 0 times 1.56491 squared, all that over 2. Alright, if I take a look at this, 0 times any number, does that make 0? And then 0 divided by 2, does that all blow up? Leaving me with 45 equals VI times 1.56491. In order to get VI all by itself, I'll divide by 1.56491. Cancel, cancel, but I can do the same to the left. Giving me a velocity initial equals 28.755444516 meters per second. And now I see three significant figures right here. So my answer is going to be 28.8 meters per second.